Pardon me? Yes. Please, ladies and gentlemen, of course, if you do not have what I have, what must you do? Ask. Okay? Aye? Aye. So, 144 is... Oh, wait, I gotta get my fancy highlighter thing here. Uh, 144 is 8 and 18. And, of course, 18 does not have a cube root, so it is 2 cubed root 18. 128 is, of course, 64. No, I lie. Sorry about that. But you could go 64 times 2, and then that is 8 times 8, which isn't, the best, because you got to keep breaking it down. But if you were to use 16 times 8, then you would be good, because this breaks down into 2 to the 4th and 2 to the 3rd, which you could then see was 2 to the 7th. You would take out 4 of them, 2, and you would be left with 8. Down here, this is, of course, 81 times 2. 81 is 9 times 9, which gives you 3, 3, 3, 3. That is 3 4th root 2. That is, of course, 27 times 4. 27 has a cube root, 3 cube root 4. And that is, of course, 9 times 12, which most of you will do that one, but then a lot of you will forget that 12 is 4 times 3. So you will take out the cube root of 9, 3, the cube root of 4, square root of 9, 3, square root of 4, 2, and leave a 3 there. 3 times 2 is 6 root 3. Some of you will have noticed that that is indeed 36 times 3 and will have just brought out the square root of 6. Any questions there? Excellent. Now we have to apply our knowledge to something we haven't seen before. But math is always the same. If there was no x there, do you know what to do? Of course you do. You would do 16 times 2, right? And you would bring out the square root of 16, which is 4, and you would leave a 2 under there. This is x times x, yes? Is that not a pair? So what comes out? X, and nothing stays under. Now you come to here, 48. Of course, you would do 8 times 6. Why? Because 8 is a cube. So you would bring out the cube root of 8, 2. But you also need groups of 3. How many x's are there? So how many groups of 3 come out? 2, x squared. How many x's stayed in there? So I've left a 6 and I've left 1 x. How many groups of 3 come out of 5? 1. Y. How many y's were left under there? 2. Any questions? Again, I didn't need to show you that because you already knew that no index means 2, so you're looking for groups of 2 factors. An index of 3 means you're looking for groups of 3 factors. Some of you may wish to actually write out 7 x's. So there's one group of 3, there's a second group of 3. If you need to do that, are you to be penalized in any way? Of course not, because you're getting the right answer. Abby.
Where did the 6 that's underneath come from?
48 is 8 times 6. 8 has a cube root. Cube root of 8 is 2. I left the 6 there. Everybody good? Alrighty then. We already did these in our notes. You knew what to do. When it was a square out here, you brought a squared under there. Well, now it's a cube root, so what goes under there? 3 cubed, which is the cubed root of 4 times 27, which is the cubed root of 108. 6 to the 4th. What does that mean? That means it's 5 times 6 to the 4th. Now 6 to the 4th is 1,296. Times 5 is 5,000. 6,000. Okay. 6,480. And 5 cube root 7 is, of course, 7 times 5 cubed, which is 7 times 125, which is the cube root of 875. And then the last bit was just putting it all together. This one cannot be changed to a mixed radical because that is 3 times 5 times 7. Are there any pairs? No. So it stays as root 105. This is, of course, 14. This is, if you've memorized your perfect cubes, of course you saw that is 216 times 2. What is the cubed root of 216? 6. So out comes a 6. We already had a 3. 18 cube root 2. 3750. Holy smokes, that's a big number. Mr. Myers didn't tell me to memorize my 4th roots, but he did tell me how to do this. I would, of course, use 375 times 10. And then, of course, I would use 5 times 73. 5, wasn't that 7? Oh, I'm sorry, 75, idiot head. And 10 is 2 times 5. And then, of course, 75, I would do 25 times 3, and then I could stop. Why? Montage. You think Abby will talk?
Because 25 has a square root.
Well, it does indeed, but I'm looking for a 4th root here. But since 25 is made up of 2 5s, and what do I see there and there? 2 more 5s to make a total of 4 5s. So I can bring out a 5. And what did I leave under there? 2 and 3, which is 6. 384. What did you break 384 down into? Pardon me? 4 and 196? 4 and 96. Okay. Then what? And then what was this one? 4 and 24. Which it gave us another 2 and 2. And a 4 and 6. And I can stop there. Why? Four is a perfect square. So there's 1, 2. There's another 2. There's another 2. And there was already a 6 out there. So what is that? 48 root 6. And this one is tricky. 180 is 18 and 10 is where most of you probably went. Then you went 9 and 2 and 2 and 5. And of course you stopped there. Why? 3 is a perfect square and there's a group of 2. So we brought out a 3, we brought out a 2, and what was already out there? Negative 2 to get negative 12 root 5. And that's how we say that as well, negative 12 root 5. If I say negative 12 root 5, I mean it's a square root. Anything else, you say it. Negative 12 cube root 5. Negative 12 fourth root 5. Harry. Okay. Now, this part usually makes kids cower a little bit because I said no calculator. How many of you figured out a way to do this without using your calculator? You had two options. What did you do, Jordy?
Well, I took the coefficient.
Uh-huh.
And, I'm obeying the rule of the index.
Uh-huh.
Because it's squared.
Yep.
I just squared the coefficient and I put it inside the square root.
Absolutely correct. So this guy in black became the root of 50. This guy in red became the root of 48. This guy in blue became the root of 54. This guy in green became the root of 28. And this guy with gray became the root of 72. And now it becomes super easy to put them in order, right? Because what's the smallest one? Root 28. So 2 root 7 had to go on the left of the number line because that's where the lower numbers are. And then we just went through. Everybody understand? Now, I said you had a second option as well. You could have estimated all of these. Right? When you get to the second one, can you almost do the same thing? Except for which? You're kind of stuck right there, yeah? Oops. You're kind of stuck right there, right? So, try what you know. This, you know, is going to be the square root of what? This one. 180. What's this one going to be? Root what? 52. What's this one going to be? Root 36. And then we're stuck with the cube root of 10. But we're intelligent young people. What is the cube root of 10 very close to? Not 9. Because 9, it's very close to 2. Why? Because it is? Okay. Because it's usually what people say when they don't have an answer. Why can't I go to the movies tonight? Because. That's what your parents say. It's because they don't really have an answer. Because there is no reason for you not to go to the movies tonight. But, of course, that is very close to the cubed root of 8, which is what? 2. So that has to be a little bit more than 2, right? Well, you know that's 6. You know that's a little bit more than 7. And you know that's almost 14. So it's real easy to put in order, isn't it? What's the lowest number? Cube root 10, because it gave me 2. Then root 36, 3 root 4, then root 52, 2 root 13, then 6 root 5. Yeah, yeah? Yeah, yeah, yeah. Now, everybody needs to be honest with themselves. It is absolutely key that you are honest with yourself right now. If you cannot simplify radicals, you are in trouble for the next 4 lessons. So, you will notice that I have provided you with another whole page of practice with answers. You need only do them if you need the practice. Okay? All right? It is on you if you need it. I personally do not really expect a lot of people in this class to have a lot of trouble simplifying radicals because of who you are. But if you do have trouble with simplifying radicals, then you must be true to who you are and practice more. Clear? All right. please turn to page 43. Excellent, which means I am not going to read it to you. Montage. You are going to do a quiz when we are comfortable with simplifying radicals. Since everybody in the room said they were comfortable simplifying radicals, what could that mean for you? A quiz could happen at any time now. Now, I have a lesson in front of you. You see the word radicals. You know we're going to be working with radicals, so it'll be a little extra practice right now, yeah? All right. So, as is previously mentioned, I do not like to read to my audience what is on the screen. It bothers me when I am in an audience. It means that the person speaking doesn't have a lot to say because they're just reading what is on their screen that they already wrote. You all know that I have plenty to say about plenty of things, so I am not going to waste any time saying something that you can all read. Right? Right. So, let us go right into this, cabbages. If I were going to add and subtract a variable, what would it look like? Here is what I mean. X plus X. What is the answer? No. Mantosh. 2x. Correct. 3y plus 8y. What is the answer? 11y. 18q minus 13q. 5q. And finally, 8x plus 3y minus 5q. Exactly. 8x plus 3y minus 5q. What is different in the highlighted one that means we couldn't change the way the left side of the equation looked? Shitu. The variables differ, right? In the first three, the black, the red, and the first blue one, all the variables are the same. And that is what we call in math like terms. Since I have already said that adding and subtracting radicals is very similar to adding and subtracting variables, what do you think would happen with a radical if I gave you the root of 3 plus the root of 3? What will the answer be? Antos. Your guess is 2 root 6. Okay, anybody else? I'm not saying if she's right or wrong. I want to see what you people are bringing to this party. Jordy. We have a 2 root 3. Do we have anything else? Nobody wishes to guess 2 root 9? Are you sure? Of course it isn't. I'm messing with you. It is not 2 root 9. Notice up here, how did we get from 1x and another x to 2 x's? What did we add? We added the coefficients that are not written, correct? What did we add here? The coefficients. Did anything change to the y? So which of these is the right answer? The second one. Because we added 1 and 1. And then this part didn't change. Here is how you could look at it. All of you remember those little things like this for x, yes? All right. So that is 1x. That is another x. 2 x's. Well, now, think of this as a root of x. And what would I have? 2 root x's, or 2 root 3. Does everybody understand? Now, do you think I would be allowed to do this? Yes or no? Why not, Jordy?
Well, because It's like saying the highlighted polynomial.
Wait a sec. I'll make it easy. I'll color it over in blue so it shows up green.
Making the variables different. Like there's no common number.
Absolutely correct. Because root 2 is not root 3. Does everyone understand? Okay. So all of you, that looks an awful lot like this very first question. What is it? The answer here. Remember, I know that you can do this in your head, but what should you do in these notes? Show the work now. So what is this really? How could we really write it? 1 root 3 plus 2 root 3 equals 1 plus 2 root 3, which is 3 root 3. What is B? Which is really 3 plus 5 root 6, which is 8 root 6. Yeah? Okay, what's different in C? Something's different. Is that blue guy part of the party? He's part of the party, but does he get to hang out with all these root 7s? No. He's like Eeyore. Eeyore's my favorite too, don't worry. So what is this really? 5 minus 3 minus 4. Why am I allowed to do that? Abby. They're all root 7 plus root 2. What does this become? Negative 2 root 7 plus 2. Now, some of you will come across teachers that actually care how you write this expression. I do not. Okay? I don't care how you dress up your answer as long as you have the answer. Some teachers, professors, instructors, whomever, will tell you that they insist that this be written as 2 minus 2 root 7, so you don't have a negative at the front. I don't care. I could not possibly care less. Okay? Okay. So you do D. What's D? I do not care. You have practiced enough. For these simple ones, you should all be able to tell me the answer to D in your heads. Negative root 6 plus minus 2 root 3, because it is 1 minus 3. Mantoge. No, because the root is only with the 7. I just switched the order. Oh, because I forgot to write it with the 2. No, the root should have been there. It's Monday morning. No, you can't call people dumb if they are speaking because they aren't dumb.
It's Monday afternoon.
It is now Monday afternoon. Abby.
What happened to the 2 that was missing?
Well, we had 1 root 6 there and we took away 2 root 6s. So how many fingers am I holding up? Take away 2. 0. Then where do I got to go? Negative. I made my left hand negative. If any of you are left-handed, I am not saying that the lefties are the negatives and the righties are the positives. I am not saying that. Although you should be aware that in a few generations, left-handed people will not exist.
Same with people with blue eyes.
Neither will blue-eyed people, neither will blonde-haired people.
I don't want my eyes to get ripped out.
Again, your eyes will not get ripped out. I am not sure how many of you understand genetics, but if I get my arm cut off by a combine harvester, my children are not born missing an arm. Yes, go. Why? We live in farm country. Everybody knows what a combine harvester is. Okay, what would you rather? If I got my arm chopped off by the tail rotor of a helicopter, is that better? No? Okay. If I get my arm eaten off by a cougar, is that better?
Why can't you say like a saw?
Okay. Fine. If I lose my arm in a bizarre woodcutting accident to some saw, my children will not be born without arms.
Sorry.
Now, as is always the case, can you forget yesterday's lesson when you do today's math? And nobody do the joke, yesterday was Sunday, we didn't have a math lesson. This is my 21st year of teaching, which means I have gone through 40 Mondays per year times 21 years. I have heard the joke. It's not funny. Stop it. So, what do I actually mean? Of course, I mean the previous lesson. Can you forget the previous lesson? Of course not. So when you are faced with something like this, you would say to yourself, Self, Mr. Myers has already taught us what to do with just that. What would you do? Mantage. You would break it down into 16 times 2. Why would you choose 16? It's a perfect square. And what is the square root of 16, Jewel? Excellent, which means what comes out and what stays in. Excellent, but as previously advertised, you cannot forget the previous day's lesson. And of course, 8 is 4 times 2. What are you gonna do with that? Now, all of a sudden, that thing that was bleh and wouldn't work is now and it does work. To get what answer? 6 root 2. Yeah? Yeah. Does that ever change? No, you just keep doing it and doing the same thing until the question is finished. Will those 3 go together? Of course not. So, what shall we do? We will simplify. What is the root word of simplify again, Connor? Yes. Simple. When you simplify something, it becomes more simple. Lily. Of course you may. So go. You may talk amongst yourselves. You need not fight this battle by yourself. Especially don't take Lily to fight the battle because she's dropping stuff all over the place. Lily, attack him on the flank. Oh, but I've dropped my sword and shield. Ah! Never mind. I am reading an interesting book in which the main character, you all know the disease that makes you age. You guys know that, right? It's called progeria. You're born normal. Again, I don't like to use the word normal. I'm sorry. You're born and you age at the same rate as all of your peers, but then at about 10 or 11 or 12, you start getting old. And by old, I mean your body breaks down as if you were an old person, a senior citizen. It is called progeria. Well, I am reading a book that is about people that have, and it doesn't really exist, at least not that we know of, that have the opposite effect. Their cells don't degenerate. So the narrator of the book was born in 1591, and he's still narrating, and the book goes all through time. And he meets all these other people that are the same. It's very cool.
I watched a movie on it.
Yeah, that's the Curious Case of Benjamin Button. Yes. There was a Star Trek episode like that too. The babies were adults. And the adults were babies. Which of course doesn't really make much sense, because how does a 6'1" person come out of a baby? But maybe they find them in the Cabbage Patch. All right, are we all good? All righty then. Does anything change here? Wait a minute, that's the same question. Oh, almost the same question. So what happens? I do the exact same thing, except what? Absolutely correct. To get now, what is happening in D? Whatever will we do? It looks different. Therefore, it must be complicated. No, because math is always the same. This was 4 times 7, and 4 was a perfect square, so we brought out the root, right? What is this? That is 4 times C. Not 7, C. So what is coming out here? 2, and leaving what there? C. C? C. C? C, C. Get what I'm doing there? I know, right? Olé! No. Not bonjour. No. What? Pardon? No. Buenos dias. Not bonjour. Buenos dias. And what is this one? So what comes out? What's funnier when you know? Okay. He waited patiently for what to write here. And then what would you do? Which is? Yeah? Yeah. Now, I need you to be aware of a couple of things. Because you will notice the next 2 pages are blank, yes? With no assignment, yes? But we have stuff to talk about. Is this allowed?
Wait, I have a giant triangle. Why do I have a triangle?
We'll get to the triangle. No. We're still on this page. Don't flip to the triangle yet.
The triangle's all the same.
On this page? Son of a motherless goat. Really? Let me see that, Samuel. Well, that's just crazy talk. That shouldn't be there. What? Pardon me?
No, keep going. No. Stop.
Okay. The triangle should not be there. Because as you can see, it is not on the teacher master copy. So I don't know how that ended up there. So, therefore, you all will work around the triangle. Okay? You could work on the triangle if you so wish. That is up to you. So, when you see this, are you adding that? Yes or no? Are you adding those two?
No.
Some of you are saying no, because why?
And a square root.
Of course you are saying that, but you should not say that, because what is the cube root of 27? So isn't this 9? And what is the square root of 16? So is this not 36? So is not this indeed capable of being added to 45? Yes. So what must you remember? You must remember math, not a series of steps. Because if the only thing you got out of all the stuff I've said this period is, if they have different indices, you can't add them, then you are going to make an error. That is why I always discuss why things can and cannot happen. Because many of you would leave that blank on a test and tell me that it was indeed already in simplest form. But now none of you will be fooled by such a thing, will you?
Sure.
Absolutely.
Of course not. Pardon me, Lily?
Absolutely.
It's probably going to happen. We'll try not to, but it's probably going to happen.
Pardon me, Jewel? So you are wondering why I was said right away, no, you silly geese, you must do this.
Yes.
Okay, because what should we always do whenever we think we are stuck? It starts with an S.
Simplify.
It ends with a Y. Let me finish my joke. It has implify in the middle of it. Simplify. So this indeed becomes... Yes?
Yes.
And there is my group of 3, so out will come 3, and now 3 times 3 is 9.
Yeah.
There is 9 root 4 times 4, yes? So out will come what? 4 times 9 is? And now it is plenty easy to add.
Got it. Cool.
Any other questiones
No, sir.
about that type of thing? Lovely. So what is the key to remember when you are adding and subtracting radicals? Right. All the math you know is part of the party. Now, I am going to ask you, now that we have discussed this, I just wish to check something. I want to see, because somewhere back here is a question that I wanted you to, or that I want you to do now that you did not have the ability to do very well before. And it is right there. Do not do the surface area part. On page 32, Wait, let me think. Whoa, 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 whoa. Not yet. I'm the worst kind of liar. Do not do that yet. We need to do one more thing. I almost made a fairly egregious error there. How could you make an egregious error? Your name is Matt. Because you spell egregious with Greg in the middle of it? Nothing. Never. When I finish what I am going to do next, I'm going to put some questions on this page, which is page 45, that will allow you to practice some of this. Okay? But first, while you have adding and subtracting in your head, let us take a quick look at multiplying. Ho, ho, ho. Now, once again, we are going to bring prior knowledge to the party. And that prior knowledge I'm going to remind you of here, above the title. What is 5x times 5x? Times 25x squared. Excellent. What is 5x squared times 5x cubed? Excellently done. What is 3y cubed times 4y to the fifth? Excellent. And lastly, what is 3x times 4y? Thank you. 12xy. Now, all of you come up in your own head with how you got all of these answers. What math did you do to get to those green answers? Do not all yell out a sentence. Have the sentence in your brain. I will wait a moment whilst you formulate that sentence. Does everyone have their sentence? Here is the way I remember it. That's what I say in my head. Then I have to think. If the bases are the same, exponent laws apply. Right?
Yes.
Excellent. Now, multiplying radicals can only occur at this point in our math careers if they have the same what do you think? What word, everything we know about radicals, do you think I am going to write here? Here are some of the words we have. We have talked base, we have talked exponent, we have talked radicand, we have talked index. So some of you think radicand, okay? And Vicky thinks index. How many people are in the radicand camp? How many people are in the index camp? How many people didn't have the guts to put their hand up? Everybody else. There we go. Okay. Because obviously you were going to be punished severely for getting the answer wrong, yes? So why risk it? Because I have been known for severely doling out punishment, yes? I am a mean, cantankerous old man. Get off my lawn, you little whippersnappers. Arr! I want to sit in my rocking chair and whittle wood. Who do you think I am? Of course it is index. Now let us discuss why. It couldn't possibly be the radicand because we were able to do this, were we not? We just lined up the xy when they weren't the same. So it wouldn't be the radicand. So we come to the second sort of decision. It must then be the index. And let's think about why. The cubed root of 3 times the root of 2. That is not doable. Why? Jordy.
Because when it became cube root,
Uh-huh. And they are going to give vastly different answers, right? They're both irrational. We're stuck. Okay? Now, if they have the same index, however, then cube root of 3 times the cubed root of 2, that becomes the cubed root of 6. Just like we put x and y together up here. Everybody understand? Yeah. Now, what do you think would happen if the cubed root of 3 and the cubed root of 2 got coefficients in front of them? We would multiply the coefficients just like we did up here to get 10 cube root 6. Everybody good? Yes. All you got to do is this. I'm going to write it out with letters. If I have a n root x times b n root y, the n's are the same. All we do is a times b, then we do the radical sign, and x times y, no matter what it is. So in the first two questions here, of course, I am going to write it out the longest way possible so you all understand it. This first one, I am going to take these letters and I'm going to write them here. There is A, there is N, there is B, there is N, there is X, there is Y. And now all we do is this. What is A? -7. Times B. What is B? 5. N is nothing there, so of course we know it's a 2. And in here is 3 times 8. And what do you get? And would you stop there? No. Of course not. Why? Because you need to simplify the 24, which is, of course, 4 times 6. And what comes out there? 2. No. So what do I do with these now? To get -70 root 6. Are we good? Everybody? Now, can anybody see somewhere in there where I could have simplified an even easier number than 24? I could have simplified the 8, yes? Which would have gotten me 2 times 4, so what's coming out? The 2. And what's already out there? 5. So now I have negative 7 root 3 times 10 root 2. Negative 7 times 10, negative 70. 3 times 2, 6. Did I get the same answer? As long as I simplify somewhere, I am going to get the right answer. Good? Go. Here, of course, I could simplify the 8, or I don't have to. It does not matter. This is, of course, 3 root 16, which is, of course, 12. Yes? Excellent. You do C and D. Go. Yes. Well, because what is the square root of 16? So what is coming out here?
You said it was optional to do 13 and 14? That's it?
Everybody should be good at C and D now. Yes? Is everybody good to D? Everyone is good to D? Abby. 6 times negative 48. Because I brought out the square root of 36. Or 3 times 96. They both equal 288. Now, E is putting the last 2 lessons together, isn't it? From this lesson, what we are doing right now, you would say to yourself, self, I know what to do if it's that, because we are doing that right now, correct? What math is happening right there? Multiplication. So this first one is 5 times 3, root what? 8 times 2, right? 5 times 3 is 15, root 16. What's the square root of 16?
4,
So what comes out?
4,
And what do we get? 60. Now, we are done with the first one. So, let's get rid of them. Well, now we've got a second one. What's that second one? Well, that's 5 times 2, root what? 8 times 3, which is 10 root 24, which is 4 times 6. Bring out the 4. 20 root 6. And, of course, it is positive, right? And then, logically, we have dealt with 3 root 2. We have dealt with 2 root 3. What is left? That to get negative, or 5 times negative 1 root 8 times 5, which is negative 5 root 40, which is 4 times 10, which is negative 10 root 10. And then am I done? Am I done? Where could I do something more? Let us look back at the lesson we just did. What allowed me to put those 3 together when adding? Same radicand. Do I have the same radicand there? So am I done? Yes. Everybody cool? Now, once again, if you have been just trying to memorize steps, this next question is going to cause you a great amount of grief. Because if you are memorizing steps, what you are going to do here is do 1 times 1 root 16 times 54. Then you're going to do root 16 times 54 is 864, the cubed root. And now you have to make a factor tree the size of a redwood. That would be silly, wouldn't it? Never mind. How could we make this better? Good. How could we make this better than trying to do a factor tree for 864? Yes? Well, you would simplify now, yes? So this is the cubed root of 16 times 54, yes? We'll just simplify there. Isn't that 8 times 2? And isn't that 27 times 2? What is special about 8 and 27? They are cube roots. So what is coming out? 2 and 3. What do they do? To get 6. What did I leave under there? 2 and 2, which is 4. Now again, if you haven't been paying attention, you are only memorizing steps. Some of you are going to bring a 2 out of there. Aren't you? No, you're not. Why? It's cube root, not square root. Okay? Okay. You do G and H. They are very, very sneaky. Well, G isn't. H is very, very sneaky. While you are working on G and H, I will write a bunch of questions on page 47, and page, 45. And then, after you have done G and H, and you have seen the right answers, you will be able to do that other question of which I spoke. Okay? Okay. So you are working on G and H right now. Are people ready to see G and H yet? No? Okay, no problem. I've only written 4 adding problems now. I'll come back to this. Let's do a few multiply E problems. Mike Wazowski? Like the guy from Monsters, Inc.? Why? I know whom you speak of. Now, of course, ladies and gentlemen, that is 5 times 3 root 28 times 63. I do it this way. You may wish to simplify here. I like simplifying here. Is there room in this world for those of us that like to simplify here and those of us that like to simplify here? Yes, there is. Just like Jonathan Swift said when he said there is room for the big endians and room for the little endians. If you do not know of what I speak, read some classic English literature. The little endians and the big endians. It comes from Gulliver's Travels, because the Lilliputians are having a war about whether you should break open the small end of a hard-boiled egg first or the big end of a hard-boiled egg first. No, it matters not. So you do not have to fight about it. What is the square root of 4? 2. What is the square root of 7? Nothing. What is the square root of 9? 3. Oh, but there's another 7. So what else may I bring here? Another 7. Did I leave anything under there? No. 15 times 2 is 30. 30 times 3 is 90. 90 times 7 is 630.
Oh, I didn't go that far. I got it.
If you simplified the other way, of course, you did 4 and 7 and got 10 root 7. Then you did 9 and 7 and got 9 root 7. Then you got 90 root 49. And then you took out the root of 49, which was 7, and you got 630. $49. Perhaps you should move closer. And this one, of course, looks a lot like the math we have already done. And it is, of course, double distribution. So you did this to get 2 times 2 root 8 times 3. Then you did this to get 2 times negative 3 root 8 times 2. Then you did this to get 3 times 2 root 7 times 3. And then, of course, you did this to get 3 times negative 3. I forgot the negative. 3 times negative 3 root 7 times 2. And then you did all of your work. 4 root 24 minus 6 root 16 plus 6, needed to change color there, plus 6 root 21 minus 9 root 14. And then you simplified everywhere you could, which is, of course, 4 times 6. What comes out? What? 8 root 6. Square root of 16 is what? 4. So that is what comes out. 4 minus 24. Does 21 get any simpler? No, so it stays. Does 14 get any simpler? So it stays. And you would be done diddly un. Okay? Okay. Now, on the video, if you haven't written them down yet, there is 4 addition questions. They are on the video. You can check it, or you can hope that I will continue to talk about them long enough for you to write down all 4. But I'm running out of things to say about them, so it's becoming difficult to continue to talk about this page, even though there is no more information on this page than what is already in front of you. I am already beginning to repeat myself and become redundant, so I'm hoping that everybody has this already written down. But even if they don't, in the interest of redundancy, it is already recorded and on the video in more than one spot. Whew. Yes. And then, of course, that was actually really funny. Everything I just said, here. And you could give this a try, but that's really, really, really difficult. Yo, am I impressed at...
It's really fun playing with.
What is the purpose of that?
It's so crazy. No, you can drop it off the reception. And you would be able to count it.
Great humor. I think you guys are gonna snap and